welcome! This is our third video in the series of algebraic equations. You can tell by the little number 3 behind my head here. And in this video, we're going to be looking at equations that are multi-step problems, multi-step equations. In the first video, we looked at one-step equations, one-step equations that could be solved either doing an addition or a subtraction. In the second video of our series, we did the same thing, or very similar. We did one-step equations that could be solved either doing a multiplication or a division. Okay, so in this one, we're going to be looking at multi-step problems. They're just multi-step problems. There's more things in the equations, more terms on either side or on both sides of the equal sign. And so, I guess we could just start with this right away. So what we want to do is we want to simplify each side of the equation first, and then we'll simplify across the equal sign. Okay, so when we say simplify, what does that mean? So what I'm going to be doing is I'm going to be looking at either side, the left or the right, and I'm going to maybe take the left side here and then say, okay, I have 1, 2, 3, 4, maybe 5 terms. It could be, you never know. 5 terms on this side, and I have to look to see if I can group together anything on this side. If there's like 2 or 3 terms that have x, I can put those all together and add them or subtract them depending on their signs, of course. And then there's 2 numbers that don't have x's, for example, then I can group those 2 together, of course, depending on their signs. And then I'll look over here to the right side and I'll do the same thing. I'll look to see if I have more than one term. If I do, then I'll see if I can't simplify it somehow. And that's always going to be a grouping thing, right? You're always going to group when we simplify. Okay, and then after we do that, after we get the left side and the right side completely grouped as simple as they can be, then we try to simplify across the equal sign, okay? And I do like making this movement. And so we're going to be grouping together all the x's, all the terms that have x's on one side, and all the terms that have numbers, or that are just numbers without the x, on the other side. And I know I always say x, that's my favorite, that's my variable of choice. It could be any letter, just so you know, okay? And what else do I need to say about that? Well, that's what I have here. That's what I meant by simplify across the equal sign. So that's basically the step that I like to take. I try to do the addition and subtraction first, and that's usually grouping together the terms that are similar, like terms. And then I'll group across the equal sign. And remember, to go across the equal sign, we have to do, losing my board, we have to, what am I doing? We have to do an opposite or an inverse operation to do that, to cross the equal sign, right? Okay, so I have my little cheat sheet here of examples that we're going to be doing. Looks like I'm going to be doing 6 to begin with, and then I'll bring the other board over here, and you guys can do 2 more. Like we always do, right? So, let's go ahead and get started. All right, this first example for the day is 6x plus 7 is equal to 37. Okay, so what we have here is we have an equation that has 3 terms, 2 on the left side, 1 on the right. And the first step that I always like to try and do is put my line where I have the equal sign, just to identify both sides, I guess, right? Now, let's see here. Is the left side simplified as much as it can be? And I guess I should ask the same question about the right side. Is the right side simplified as much as it can be? And the answer is yes. Here on the left side, I have 2 terms, but these 2 terms are different. I have a 6x and a 7. Now, perhaps if they both had an x, like 6x and 7x, then I could simplify them and group them into one term. But because they're not like terms, that's as simplified as it's going to get on this side. Same thing on the other side. Well, the other side just has 1 term, so it's not like I could make it any smaller. one term is great. All right, so the second step that I had mentioned, or that I had written on the board earlier, said, okay, after each side is simplified, and we can just basically say, check, yeah, it's simplified. Or either side are simplified. So now we have to see if we can simplify across the equal sign. In other words, out of these 3 terms, 2 of them are like terms. And I hope that you all can see that it's the 7 and the 37. Now the idea here is we always want to get x isolated. But before we do that, we have to group all the terms that have x on one side of the equation, or the equal sign. And it doesn't matter what side. You could group them over here, you could group them over here, it doesn't matter. And then you want all the terms that don't have the variable or don't have the x on the other side. And so, as you can see, we have all the terms that have a variable or the x on this left side. So it makes sense that I want to move all the other numbers that don't have the x on the other side. So that means I got to get the 7 over there. And remember, just to repeat, to get the 7, we have to do its opposite operation. That's going to be a subtraction in this case. Or I guess you could maybe think about it like, what do I have to do to the 7 so that it equals 0? So that I can eliminate it from this left side, right? Well, that is going to be a subtraction. Opposite operation. Inverse operation is probably a little bit more correct terminology, right? All right, so that cancels out, kind of gives us a 0. I can move the 6x down here. And what I do to one side, remember that, right? We always have to maintain equilibrium. So if I take 7 away from this side, I have to maintain the equal sign. I can't change the equals. So I have to make sure I do the same thing to the other side to maintain that balance. So what I did over here was subtract 7, and that's what I'm going to do over here on the right side, is also subtract 7. So that subtraction, I'll just write it down here where we have our equal sign. It's going to give us 30. Okay, so 6x is equal to 30. It's getting easier. I think at this point you can probably see that it's going to be 5, because this says 6 times some unknown number. It's going to give us 30. Obviously 6 times 5 is 30. But we're not done yet. I like for you guys to be able to see it, but I still want you guys to be able to show it on your work. Okay, write it down. Practice the steps. All right. So what do I do here? Now this is our last step. Now, so we have all the x's grouped on one side, all the terms that don't have x grouped on the other side. This is the last step. So if you remember in the second video, a lot of our examples were like this, right? We had a one-step equation, because this is going to give us, we only have one more step to get to the answer. And to solve this one-step equation, we have to divide, because that's going to be I'm not going to pull it over. It's going to be the inverse operation of this multiplication. So 6 is multiplied to x. So the opposite or the inverse operation is to divide. So we divide by the same number and the same sign. You can get into the habit of putting the sign there. If it doesn't have a sign, it's positive. All right. So you want to divide by the same sign and the same number, okay, that you're trying to eliminate. So 6 divided by 6 is 1. And I've already said this many times, I'm sure, but 1x is actually equal to x. All right, so ta-da, x is isolated on one side of the equal sign. But remember, we have to maintain equilibrium, so I have to divide the 6 to the other side too. And I can put my signs, why not? And again, like I said, we knew it was going to be 5. 30 divided by 6 is 5. Positive divided by a positive is a positive. Okay? So that's the first one. Ta-da! All right, so this was just an example where we have 3 terms. We didn't get to simplify on either side individually, but we did get a chance to simplify across the equal sign. Because our goal is always to get all the terms that have x on one side and all the numbers that have no x on the other side. And then you can do that last operation to pull them apart to get x completely isolated. Okay? All right, let's do another one. All right. This one says 6x. I'm going to write a little bit smaller. I'm pretty sure. Oops, sorry, it's not 6x. Like I was saying, I'm going to write a little bit smaller so that I have some more space here so I don't run out of space. Hopefully you all can see these things. So it says 6 minus x plus 12 is equal to 10x plus 7. Boom. All right. There we go. So I hope you all can see that. Well, I've been saying y'all a lot today, huh? That's kind of strange. Anyway, all right, so I put my line. So I put my line, and I like to count terms just to make sure I know what I'm looking at here. I have 1, 2, 3, 4, 5 terms in this equation. So clearly it's going to be a multi-step problem, a multi-step equation. So I'll look to the left side first, and I have 1, 2, 3 terms here on the left side. And then I like to ask myself, well, out of these 3 terms, are any of them like terms, or are any of them similar? And the answer is yes. I have 2 of them that are just numbers. And if this one doesn't have a sign, you can get into the habit of putting a sign in front of it or to the left of the number. That's where the signs go. The sign goes to the left of a number, okay? All right, so I have 3 terms. 2 of these are like terms. The 6 and the 12 can be grouped together, depending on their sign, of course. I mean, the sign will let me know if I have to subtract them or if I have to add them. Remember, if they're same sign, we add, keep the same sign in the answer. If they're different signs, we subtract, and the larger number will win the sign or keep the sign in the answer. All right, so they're both the same, so plus 6 plus 12 is plus 18. And I'll just bring down my minus x. Okay, so I simplified from 3 terms down to 2 terms, okay? Now, I'll just bring this down because we didn't do anything over here. Well, I guess we could ask ourselves, right? Is there anything that can be simplified here on this side? I have 2 terms. I have one with a 10x, one term that has an x, and I have another term that doesn't have an x. So, no, it is as simplified as it's going to get. Yeah. All right, and you can put signs, why not? You know, it's a good idea. I usually find that a lot of my students get answers wrong because they get a sign wrong. So if you get the sign wrong, you want to get in the habit of moving that sign around and being very explicit about writing every sign all the time to help you maintain organization, right? Not lose a sign somewhere. All right, so now left side is simplified, right side is simplified. Now I have to simplify across the equal sign, and here I go again doing this movement. Okay, so we have to what? We want to group the x's on, well, before we move on, I want to talk about inequalities. We're going to be looking at inequalities later on in the future, right? I can see the future and I know we're going to be doing that. Inequalities, they're the things that have these little signs like this, greater than or less than. And when we do inequalities, and also the less than or equal to, anyway, we'll get to that when we get to that. But what I'm trying to say is, when we do inequalities, they're very much like equations, except that there's one more step that kind of changes things up. There's one big difference between equations and inequalities, as far as when we're doing operational tasks. I guess when we're solving them, I guess is what I'm trying to say. And one thing to get into the habit of doing now that will help you when we do inequalities in the future will be to group the terms that have x on the either side of the equation where that term will remain positive. Because when it remains negative, that's when when we do inequalities, you'll have to do a special trick. And you have to remember that special trick. But I prefer just remember to keep x positive. It makes it a little bit easier, I think. I don't know. Anyway, so I have an x over here, and I have an x over here. Now I want the x to be on one of these sides all grouped together, but I want to make sure and figure out which side is x going to remain positive. So if I move, let's just try this out, because I know a lot of my students want the x's on this left side. I don't know why they always want that. It doesn't matter, but preferably where it's positive. So let's just experiment here. Let's subtract here. Let's move the 10x. We have to do the opposite operation. That will eliminate it. That will give us 0, right? And then we have to do the same thing over here. So this is kind of like a 1. Remember that, right? It's a 1x. They don't put the 1. They'll never put the number there, but you have to understand there's like a 1 there. And so negative 1x, negative 10x will give you negative 11x. So if I group my x's on the left side, it'll be negative. And that's the thing I'm trying to avoid. It's just good practice if you can start grouping. My suggestion, you don't have to follow it. We could still solve this equation with a negative x. It's not like it's impossible or anything. You just, when it comes down to separating the negative 11 from the x, you'll just divide by the same sign and the same number, and that'll make x positive, no problem. But when we do inequalities, you might want to rethink that. You might want to think about trying to group the x's where they're going to be positive. So I think now you know that if we group the negative x over there to the right side, that's where it's going to be positive. So let's go ahead and do that. I'm going to get rid of this imaginary, well, it's not imaginary, but that little 1 that I wrote there. Okay, so to get rid of this x, I have to do its opposite operation, which is going to be an addition. So negative x plus x will be 0. Okay, that'll be 0x. And I do the same operation, plus x, or I add x to the right side. Okay. Now I know I write all these little steps and I get all busybody with it, right? Now if you have a lot of experience, clearly you're not going to do all these small steps, you know, just to be so explicit. But well, since I'm showing you, I want to make sure you know exactly what I'm doing, okay? Okay, so 10x, and we add another x to it, we'll get 11x. I'll bring down the 7 and my equal sign, and I'll bring down the 18, the positive 18. I get used to writing the sign. And since I have all my x's grouped on the right side, that means I should group all of my numbers that don't have x, or my terms that don't have a variable, over here on the left side. So let's get rid of the 7. Let's move this group the 7 over here with the 18. Opposite operation. That will eliminate it. We do the same thing over here. And 18 minus 7 is 11, equal to 11x. Now, can you all see that? Is there enough space here on my screen? Yes. And this is our last step, right? We're just gonna separate these two by dividing, right? Dividing the same sign and the same number, and that'll cancel out the 11s, and that will leave me with x all by itself. Okay, I just brought it down, equal to. But I gotta make sure I do my division over here too. 11 divided by 11 is 1. Okay, well that gave us 1 over here too. That's a 1x, but 1x is equal to, right, x. So, I'm like talking to myself, right? Well, it's good to talk to yourself. You know, you get expert advice like that, right? Okay, gotta talk to the expert. Anyway, so that's the answer. X is equal to 1, all right? So again, we simplified the left side. This one had space, or room for us to simplify the left side. The right side, was already simplified. So then we started grouping across the equal sign, getting the x's on the side. That was positive. That's just my suggestion. You don't have to, but my suggestion. And then we grouped the numbers to the left side, and then we did the last step by separating the numbers from the x to leave x completely isolated, and that gives us the answer. Okay? All right, let's do another one. Now we'll have 11x minus 10 equal to 8x plus 5. Okay, so my first step that I like, that by now, is to put the line. Now the left side and the right side, they look to be already simplified individually, like the left side is already as simplified as it's going to get, and then the right side, same thing. Because they're different terms each side, right? I have a term with an x and a term with no x. A term with an x and a term with no x. So that means I can't simplify each side. They're already simplified. But I can group across the equal sign, and that's what I got to do. Now I want to start thinking about getting all the x's on one side and all the numbers on the other. So let's focus on the x first. Which side of the equal sign will x be positive? On the right side or on the left side? Give you a second to think about it. Well, it's going to be here on the left side. Okay, so let's get rid of the 8x. And that'll give you 0. Just by, again, remember that the 8x is a positive, so opposite operation. To group it will be to subtract the whole term over to the other side. So minus 8x over here. A pow! And I guess I can put my sign. So 11x minus 8x is 3x. And I'll just bring down my 10. I know some of you are probably looking at it like, well, why don't you just pass the 10 over there in one step? You can. Again, I'm just being very explicit about my little steps here, okay? So I have all the x's over here, and they're positive. Yay! So now we want to pass the numbers over to the right side, okay? So let's go ahead and do that. So now negative 10 plus 10, 0. And 5 plus 10 is 15. Positive 15 if you want to put that. It's a good idea. All right, I just brought down the 3x. So now this is our last step. We have all the terms that have x on one side, and they're positive. Yay! And then we have all the numbers or all the terms that don't have x on the other side. Okay, so now it's time to divide, because this says 3 times x, and I'll go ahead and pull it. Ta-da! So something that's times, the inverse operation is division. We already know that. I like to repeat myself a lot. So x is going to be equal to 5. All right? I guess I had a little bit more room. I got scared, got paranoid. Okay, so now Yeah, x is equal to 5. 15 divided by 3, 3 divided by 3 is 1x. 1x is x. 15 divided by 3 is 5. All right, let's look at another one. I'm about halfway through my little example sets. And you guys got 2 more to do. Then I have to do those ones too, but that's okay. That's why I'm here. All right, this is going to change it up a little bit. I don't know why, but that 6 didn't look good. 6 times the addition of 2 plus x. Oh, parentheses. Do you guys remember that? You guys remember how to do that? Remember? Or not even? Remember. If you're from New Mexico, there's one of those, just the, I guess the jargon of some local people. We say member. All right, so equal sign, my line. All right, so I have another color here. Remember, what is this? Can the left side be simplified? The answer is yes. The right side, no, because these are different and they're already, that's as simplified as that right side is going to get. But over here, we have a distributive property, right? We have this 6 being multiplied by 2 terms inside parentheses. So remember that we have to multiply the 6 to each term, basically. Keep in mind that you're multiplying, and when you multiply, you got to keep in mind the rules of multiplying positive and negative numbers, okay? So this is a positive, so is a 2. Positive times a positive is a positive. 6 times 2 is 12, so positive 12. Positive times a positive is a positive. Remember that I'm multiplying, so I'm not just going to bring down that positive straight away. That's not what I'm doing. This positive is not this positive. This positive is the product of multiplying these 2 together. Okay, I just want to be very clear about that. All right, so I brought my positive down. 6 times x is 6x equal to, and I'll just bring all this stuff down that we didn't use. All right. Okay, now, the left side is as simplified as it's going to get because I have a term with no variable and a term with a variable, and they're not like, so I can't add them together. Can't group them together, but now I can group across the equal sign. Let's start with the x. Can you see, if I move my head out of the way, can you see which side of the equal sign will the x, or the term with the x, stay positive? Wow, that did not come out clear at all. Gosh, on which side will the variable with x, the term with x stay positive? I better just get back to it because I can't talk. All right, so it'll be positive on this side, right? On this left side. Subtract the 5x over here to eliminate it, and we subtract because it originally was a positive. So that eliminates it. It equals 0. I'm not going to write the 0 here just for the sake of space. And I do the same thing over here. Add 5x. And 6x minus 5x is 1x. But remember that 1x is just, yep, that's right. I think I heard somebody say it, x. All right, so I'll bring down my 15 over here on this right side. And my x is positive because the larger number keeps a sign when we do a subtraction like that. And I'll bring down my 12, my positive 12. So I have all the x's over here on the left side. That means I got all the other numbers that don't have a variable on the right side. So that means the 12, you've got to go over there. So what do I do to this positive 12 so that it equals 0? I subtract. And I'll subtract. Gone, I have x isolated, yay! And it's positive. 15 minus 12 is positive 3. All right, how's that sound? Good? Good, good. I have 2 more. All right. And the next one will be for us 3 times the subtraction of x minus 9. And this is also subtracted with a 2. Minus 2 equals, I'm like surprised, wow, okay. 35, minus 35. Okay, first step, I like to put my line. All right. And again, the right side I think is very obviously simplified. There's only one term, so there's not much we can do over there. But this side, we have another distributive property, so let's go ahead and get to work on that. I like my little arrows, and little sound effects. Now, 3 should be positive, because it doesn't have a sign. If it doesn't have a sign, it's positive. X is also positive, because it doesn't have a sign to its left. And I think we're ready to rock and roll. Let's do it. So, we know that the 3 is multiplied to each quantity inside, or each term that is inside the parentheses. So, positive times positive is a positive. 3 times an x is a 3x. And we just write them together to show that they're multiplied. And again, okay, now we don't just bring down this negative. We don't do that. We have to multiply to get that sign. So positive times a negative is a negative. All right, 3 times 9 is 27. Minus 2, barely squeeze it in there, is equal to negative 35. All right, so now this left side is still not simplified, or it's still not as simplified as it can get. So we got rid of the distributive property, but now I have these two terms that are like terms. They're similar terms. I can put them together because they both don't have a variable. No x with them, right? So negative 27, negative 2, what is that? It's negative 29. Negative 29, 3x, positive 3x, and I'll bring down my 35 again. So finally, well, after 2 or 3 steps, we're down to the left side is simplified now. So now let's try grouping across the equal sign. So now we know that all the terms that have x are here on this left side. So that means the 29 and all the other numbers, that don't, obviously just the 29, has to go over there to the 35, right, to the right side. So what do we do to negative 29 so that it equals 0? We do the inverse operation. Okay, and that will be 0. And then we do to one side, we do to the other side. So let's go ahead and add 29. All right. Now, okay, so I'll bring down my 3x over here. And that's going to be equal to, what is that, negative 6? I think. It's kind of strange when you look at it like that, right? Remember that we're subtracting different signs. You subtract them, and the larger number, in this case 35, will keep the answer, or keep the sign in the answer, okay? Again, this is where a lot of students get confused, man. They get confused when they're multiplying or dividing, but multiplying, and there's a rule with the signs there, and then we have another rule with the signs over here when we're adding or subtracting. This is where a lot of students get mixed up. Believe me, don't feel bad if this is the bane of your existence, those signs, right? It's difficult. It takes practice to understand which rule to use when. And there's 2 distinct rules when you're working with signs. Remember that. When you're multiplying, dividing, and when you're adding and subtracting. The signs they're different. Okay, there's different rules. Go back to the video. There's a video on that somewhere. I'm sure you can find it. All right, so let's go ahead and divide these 2 to separate them. So this is our last step. To get x completely isolated, we have to divide, because this says 3 times x. So we'll just divide by that 3. 3 divided by 3 over here, and negative 6 divided by 3 over there. That will give us positive 1x, and 1x, you just write the x. Can you see that? Yes, y'all can. One more y'all, right? And then this division, again, it's different than this, but we're not adding, subtracting, we're multiplying, dividing. This is a division. So negative divided by a positive is a negative, and 6 divided by 3 is a deuce. It's a 2, and that's not the prettiest 2, is it? But I think you guys get it. It's 2. Okay. All right, let's move on. All right, let's move on now. I have one more example before your little homework assignment. All right, let's do this one. X plus 11 minus 3x equals 20. Put my line, ba-boom. Ba-boom, plus 7x. All right. I know I make noise. I make sound effects. Okay. Right side looks simplified. These are different terms. They're not like terms, so that means that I can't group them together. So that side's ready to go for across the equal sign grouping. But this side has 3 terms. 2 of them have x. 2 of them have variables. So we can group those together. We'll go ahead and do that right away. So positive x minus 3x, what do? We subtract them, and the bigger one wins the sign. So the bigger one is the 3, because this is like a 1, remember, but they never put the 1. So I'll get negative 2x, right? When I put these two together, plus 11, just bring that down. And I'll rewrite this one for this side. Okay. So, again, I always ask you guys, which side do you think that the x will be positive? On which side, the left or the right? Where will the term with x remain positive? Can you see? It's going to be over there on the right side. Now I'm going to go ahead and do that. Okay, you can move it over here, but, you know, x doesn't always have to be on the left side, okay? Now let's go ahead and pass the 2 over there. How do we do that? We eliminate it by adding or subtracting because we're grouping. And grouping is always going to be an addition or a subtraction. So we'll add to both sides, the same thing. Remember, I can only add the 2x to like terms. I could not add the 2x to the 20 because 20 doesn't have an x. Okay, they're not like terms. So over here, they eliminate. And then I have an 11 over here. I'll just bring that down, positive 11. And I have, I can bring down a 20. Ooh, okay, now 7x and 2x is positive 9x. So I have all the x's over there on the right side. Now I need to move the numbers, or in this case, the 20, over here to this side, to the left side. All right. And that eliminates. I'll bring down the 9x. And equal to, well, I have to subtract 20. That's what I did. Got to do the same thing to both sides. And plus positive 11 minus 20 is 9, or negative 9, I should say. Remember, the bigger number will win the sign. Different signs, you subtract. When you're adding or subtracting, you'll subtract them. And the larger number will keep the sign. Remember that. All right, so we'll divide, ba-boom, to both sides, leaving x isolated. Now, I'm not sure if you can see that. Yes, you can. Yay. All right, x will be equal to, well, hang on. Let me rewrite that. Okay, it'll be equal to negative 1. Remember that. Now we're dividing, so negative divided by a positive is a negative. Negative 1. Ba-boom. Okay, cool. That's it. I'm done for the moment. I will put 2 examples up here for you all. I don't know what's up with me today. That's so strange. Y'all. All right. Dun-dun-dun. Da-da-da-da. Okay, so we have, this first one is long, so I had to write it really small, so I hope you can see that. I'll read it to you just in case you can't. 9x plus 6x minus 12x is equal to, that's an equal sign, minus 7x plus 2x minus 12 plus 5x. All right, and then the second one I want you all to try and do is this one that has 2 distributive properties on both sides. Well, 1 on each side, but 2 in total. 4 times the addition of 2x plus 5 plus 4 is equal to 3 times the quantity, or 3 times the subtraction of 5x minus 6. So go ahead and pause your video, see if you can do these, write them down. I hope you guys can do it. Let's see what you do, see what you get. Now I know some of you are probably looking at that first one like, gosh, why is it so long, right? Why is it so long and so difficult? How'd it go? What'd you get? Did you get the right answer? Were you surprised? Maybe not, maybe. If you did it, you might be surprised. I don't know if you did it. So I'll go ahead and write it. It said 9x plus 6x minus 12x is equal to, put my line right away, minus 7x plus 2x minus 12. Oh, I'm getting tired of writing. My goodness. Okay. Yep, it fit. It's so long I wasn't sure. Okay, so let's take a look at the left side first. I think it's obvious that both sides have some simplification that needs to be done. Let's go ahead and start over here. I have a positive 9x, positive 6x, and a minus 12x. All 3 terms have x, or all 3 terms are like terms, meaning that we can group them together, and that's what we're going to do. So, oh, sorry, my eyeball itches. So 9x plus 6x is, what is that? That's 15x, I believe. 9, 10, 11, 12, 13, 14, 15. Yeah, it's 15x. Okay. You know, again, it's okay to use your fingers. Gosh, people, don't take yourself so seriously. So this whole side, oh no, sorry, not this whole side, just these two terms is all I simplified. 15x minus 12x, and then these two, when you combine them, you'll get a positive 3x. Okay, so 15 minus 12 is basically what it is. All right. So this side is all pretty and all simplified down to one term. Awesome. And now let's go ahead and look on the right side. So that we have, you guys can see that we have 4 terms on this side. Out of these 4 terms, 3 of them are like terms, the 3 that have an x or a variable. So let's go ahead and group them together. Well, you know what I can do? I can group together the 2 positive ones first, the 2 that are kind of more alike than the negative. Okay, so 5x plus 2x is positive 7x. And I'll go ahead and bring down my 12. I brought down the negative 7x and the negative 12, but I added those 2 together, right? And I asked if you guys might have been surprised when you did it, because these 2 completely cancel each other out. It's like owing $7, you pay your $7, you owe 0, right? That's gone. So really that whole side that looked so big and long and complicated, it was just one term, it was the 12. In other words, that side didn't have any x's because they canceled each other out when we simplified. So now we're down to this one-step equation that requires a division to solve. So we'll divide, division because these are multiplied, so we have to do the inverse operation, right? And we'll divide by the same sign and the same number that we're trying to eliminate to both sides. We get x is equal to, negative divided by a positive is a negative. 12 divided by 3 is 4. So our answer is a negative 4. Okay? Sweet. So we got one more, and then I can go have lunch. All right. I don't know if the camera's picking it up, but my stomach has been making a lot of noise. All right, so 4. Not that you guys care. I mean, seriously, like, wow. TMI roll, like, dude. All right. Okay, equal to, what is that? Equal to 3 times 5x minus 6. Okay. So how was this one? Was this one hard? I don't remember this one. Okay, let's go ahead and do it. So again, we'll start with the left side. Why not? You can start with the right side if you want. Doesn't matter. We'll start with the left. And it's very obvious that we have this distributive property that we need to eliminate. We need to simplify that. So let's go ahead and do it. Remember that distributive property means multiplication of a number that's outside parentheses and that's being multiplied across every term or to every term that's inside the parentheses. Okay, so I like my signs. If they don't have a sign, they're positive. Positive 4 times positive 2x is positive 8x. And positive 4 times positive 5 is positive 20. And I'll bring down my 4. And then just to finish this side, obviously these are going to group together and be 24. Positive 24. Okay? So let's go ahead and do the distributive property that we have on the right side. We have a positive and a positive. Okay, so we have positive 3 times positive 5x. It's going to go with a positive 5x. No, 15x, I'm sorry. Okay, and then positive 3 times the negative 6 is a negative 18. All right, so that's it, right? Not bad at all. But now we have to group across the equal sign. Right, and so, again, I always like to ask you guys, which side do you think x will remain positive? The right side or the left side? The answer is, drum roll please, it's going to be on the right side. We should move the 8 over there to the 15. So we'll subtract the 8x over here to eliminate it. Subtracting because it's its opposite operation. That will eliminate it. What we do to one side, we have to do to the other. So we'll subtract 8 from 15. And what would that be? 7, I believe. I believe it's 7. x positive minus 18. And over here, positive 24. All right. So now we'll pass the 18 over here to the left side to group all the numbers that don't have an x on one side. And that means we'll add the 18 to both sides, eliminating it on the right and bringing it over here to the left. So 24, wow, what is that? 24 plus 18 should be 42 is equal to 7x. And I think I'm running out of space, and I am, darn it. All right, so the last step is going to be dividing both sides by 7. That's because we want to separate the 7 from the x, and they're together by multiplication. So the opposite or inverse operation is division. And we're going to divide both sides by a positive 7. Okay. So positive 7 divided by positive 7 is a 1x. You can't see that, can you? Yes, you can. Wow, I didn't know about that. Okay, so in fact, I'll just move this up a little bit. And 42 divided by 7, or a positive 42 divided by a positive 7, will be equal to a positive 6. All right. Okay, so that's it. Hopefully you guys got the answers right. Remember that when you're doing these multi-step problems, it's all about keeping things organized and simplifying, grouping together the things that can be grouped together before going across the equal sign. In the next video, you're going to see we're going to be doing fractions, and we're going to get into it pretty good. And I think probably in the next 2 videos, we're going to get into equations that have fractions. And that's where things kind of switch up. If you notice, we've been saving like the division. Again, we haven't had a multiplication because none of these have fractions. But we're always left with like a 7x or an 8x or a something times x. So in other words, our last step is always division. And there's a reason why we do it as the last step. You'll see that in the next video. So good luck, keep studying. Don't get frustrated. Remember, there's lots of little skills that we have to know, especially the signs. You know, don't get the signs mixed up. That's really where a lot of students make their mistakes when they're learning how to do these kinds of multi-step equations. So, good luck, and I'm going to lunch.